Okay, good afternoon, everyone, and welcome to the second large system session from this year's virtual GSE conference. This is session 9D, zOS software management and deployment from OpenShift, that we've got Chad from IBM is going to walk us through. Please feel free to post your questions in the chat as we go. We'll try and find an opportune moment to interrupt and ask them as we go. I will slip the feedback, so don't forget to submit your feedback. I'll slip the feedback link for this session into the chat as well. So please remember to submit your feedback at the end of the session. Chad, without further ado, over to you, sir.
All right. Thank you, Joe. And good afternoon or good morning or wherever you are in the world. Thank you for joining us today to talk about some zOS software management and deployment from OpenShift. So my name is Chad McIntyre. I'm the lead architect for IBM Open Enterprise SDK for Python on zOS. So let's kind of advance here and talk a little bit about what we're going to talk through today. So you may be wondering why I'm here, as the Python lead architect talking about this. This is a topic near and dear to my heart, partially because we see a lot of questions and a lot of intrigue around how do I deploy modern languages and things of that nature into zOS instances. So I'm here to talk about a new way that we've seen here that we think has promise and benefit for other use cases. So without further ado, I'm going to take you through sort of what the current path looks like. So what the current trajectory for installing a modern language on zOS is, the pains and the various gristle that's involved with that. Beyond that, I'm going to then talk a little bit about what this IBM Z and Cloud Modernization Stack product can do. So in other words, what it's going to allow us to do differently and better than what we can do today. And then we'll move on to a few concrete examples just to motivate, because I think that's where it really starts to show, oh, this is, the thing that's being blocked or gated for me today versus what we've had traditionally. So I do want to briefly touch on what IBM Z and Cloud Modernization Stack is, in case you haven't heard of it. At a high level, it's a stack of products that are meant to facilitate or enable modernization across the various zOS systems, right? So in various ways, you can ask the question, what does modernization mean? So within this, there's a bunch of tools that enable things like application analysis. So your typical kind of, what does this change impact, things of that nature. The idea of creating and deploying APIs, this is, part and parcel, and I'd say bread and butter of what people do today to expose or, enable modernization with, some of their existing zOS assets. Things like cloud native development. So basically developing the cloud first and then deploying onto on-prem and things like that. And then standardized automation frameworks, right? And so here, this little part on the right is the part we're going to zoom in on today, which is this notion of self-serve access to zOS environments in dev and test. So you can see how this is going to be an interesting thing when it comes to languages and things of that nature. So with that, let's take a little tour through kind of what it looks like today before this product. So, modernization developers depend on the ability to actually rapidly adapt and iterate, right? So this is a key thing that is part of modernization. You want to be able to get in, try some things, learn some things, and pick a direction quickly. Okay, that's really key for modernization. Beyond that, you want to have the fact that these needs conflict with some traditional zOS environment management practices. So you might recognize this notion or this issue where there's either change management or some kind of heavyweight process in front of getting things installed on zOS hosts and things of that nature. Beyond that, we have these critical dimensions that impact sort of that velocity, right? They add friction, they add sand into this, and so they decrease your velocity. So the important dimensions here, the things I want to kind of emphasize that are key for this, right, are being able to explore language choices, right? So today you don't see this, we're an X language shop, right? We are, people are looking at all kinds of questions around, what's the best language for this specific given purpose, and that requires them to explore the languages, right? Hey, let me go see what Go does for this, or let me go see what Node does for this, right? And so, the why here is being able to do that experiment and to do that in a very efficient way is very key. that's challenged today by the fact that to get these products, right, is a bit of an onerous task, right? Even to know, oh, one, there is a product, two, where to get it, and then three, how to get it, right? Am I getting the SMP version? Am I getting the PAX version? What version do I need, and what version can I run? Things of these natures, right? So these are all challenges to that specific point. We also need quick access to language environments, right? So you want to be able to not be, oh, I have an idea to do in Python, but it's going to take me 2 weeks to get Python installed on my kind of, I'm going to lose my momentum. I'm going to lose my ability to do that. Something's going to come in and disrupt me, right? So kind of that back and forth, issues between admin and deploy and sort of what it takes to get something installed is really something that kind of gets in the way of being able to rapidly do things. And then quick deployments and redeployments. So I think one of the key things you see in the more distributed platforms, right, is this ability to kind of, get rid of that, I want to start over type of thing, right? And this is a very painful thing today in the zOS environment, where you have these more rigid controls and more rigid structures around how to deploy software. So the more we can do to kind of get rid of those roadblocks, the better it is for us to be able to develop. So to motivate that a little bit with a concrete example, right? This is what it kind of looks like to get a Python environment today on a zOS host, right? So first and foremost, you need to know that you need Python, right? You submit your request, you kind of have to go through the whole, okay, you want Python, what version of Python do you want? And things of that nature, right? So you have this back and forth and this kind of, fact-finding exercise to get people there. So you finally get down and you get Python involved or installed, and then you understand that, oh, wait a minute, I also need the C compiler installed so that I can build a package that I'd like to use from PyPy. So that nets out to another request to system programmers and things of that nature to say, hey, I need the C compiler. Okay, which C compiler? And things of that nature. And so by the time you get down to this, right, and then you could repeat this one more step with ZOAU, right, where you have this, oh, and then that package is really useful, but it requires a system programmer installed, right? And so you see this kind of ad hoc discovery process and sort of this iterative back and forth thing. And you can imagine that this is a very churn heavy thing. And so we've seen this with customers quite often, right? So the challenges here are, right, even with that in hand, right? Let's say you want to also try Node. You have to go through that same process with Node again, or Go or Java. And so this is a really, really painful thing that happens over and over. And depending on who and how it's done, it could be repeated within the organization as well, right? So another group wants to do the same thing or things of that nature. So very, very, very troublesome. The disparate nature of these products also means that there's no standard approach to bundle and deploy related products, right? So if you're building an application, let's say I've got, a Node front end to some Python automation, something along those lines, right? That's a nice modernization statement. But today, to be able to repeatedly deploy that, you kind of have to understand, oh, okay, I need this node, I need this Python, they have these differing, or these two different requirements, I can't mix that version with that version, things of that nature. So you end up with this sort of hard to understand and hard to grapple with set of requirements that you need to manage yourself, right, in some way that's external to the tooling. The other fact here is modern languages are fast moving. So if you look at Python and Node, they're sometimes releasing a version or two per month, right? Depending on various things, right? So being able to keep up and keep pace at that point becomes even harder, especially in the face of what we've just discussed, right? Where we have this back and forth, right? It's like, oh, I don't want to go change that environment again, or we're not in a change window or things of that nature, right? So, so it becomes very challenging to be able to deploy these kinds of combinations and these types of things in a way that's useful and enables you to maintain development freedom without some kind of help, right? So that brings us to IBM Z and Cloud Modernization Stack, okay, which is a more modern approach. So in this case, this product here offers a rich set of products and programming languages centered around cloud and modernization development. I want to zoom in, as I mentioned, on specifically the aspects that relate to installing and deploying compilers and programming languages, because these are the key things that people are using on zOS, okay? So the nice thing here is that the language products are all uniformly hosted in IBM Container Registry, one source. So I alluded to earlier this notion of, oh, I need to kind of go find, okay, where's the node? offering? Where is the Python offering? Where's the Go offering? Things of that nature. In this case, all that goes away. I have entitlement to one set of stuff in the IBM container registry, and that gives me access to Node, Python, Go, Java, and a C++ compiler. All installs are driven from a uniform experience. So this is the key part here, right? So you can kind of see how things are already starting to improve. We have one place to go to get things. We have one way to go to do things, right? If you go through this today, and I'll take you through sort of what it looks like on a subsequent slide here, you can see how powerful this specific part happens. Installs can happen in separate customizable and in unique installation spaces on zOS. So this is key, right? So we talked a little bit about this notion of, a system programmer or, site rules around, we need to manage or maintain that. And there's good reasons for those. And those may still have, a completely valid reason for existing and living, right, even in the presence of this. However, if we could enable another space where, it was sort of a free innovation space where let's install and target installs for various products into this space, what that enables is flexibility, right? So on the one hand, you can keep good control over your deployed and production spaces. That's fantastic. But on the other hand, you can enable development, right, and innovators to be able to get that kind of flexibility and that freedom without kind of paying for this overly onerous process in terms of getting software installed. The latest versions of each of these languages come in and are automatically available to you there. So again, no needing to play, update, catch up, and things like that, and monitor and things of that nature. So it's a nice way to be able to say, I'm just going to pick up the latest one here. And then the other point here is these are easily repeated on other hosts, right? So if you're looking at one of these typical workflows we see today, where you sort of got an AD environment, right? You can easily let this thing kind of, repeat this process across those AD environments. So let's say you set up one, I'm going to try a Node Python app. Okay, that didn't work out. Let me try Python and Go, right? So let me get a new environment. I'll deploy the tools there, and then take it from there, right? And so it's very easy for that kind of thing to iterate. So the thing here is this approach is very similar to modern techniques like building containers. So you're starting to see the model converge here. This isn't quite containers, and I want to be careful to make sure that that's clear. But it's moving towards that notion of identifying a prerequisite product and version, and then having it deployed using some kind of automation to a target environment. So just a little bit of how it works. So at a core level, right, it's a fairly simple thing in Z and modernization stack, and we'll take another look in a slide to kind of put some of these terms in context for you. But basically, the idea here is you locate a product sub-operator. So a sub-operator is basically, I want to install Python, okay, on a zOS host. With that, you basically create an instance, okay? So these are all done in OpenShift in Cloud Broker. From there, you say, okay, I want to install in this specific location on this machine, right? So let's say that you're managing your personal development sandbox or something of that nature. So you can target the install over to that space over there. Okay, so then you invoke the sub-operator. So what that does is that invokes a process which installs or basically runs an install on the zOS environment in the target location that says install Python 3.10.5 in this specific location. Okay. And then the automation installs with it an environment script for being able to use that install. So this is another key benefit that comes from this approach specifically. Because this script is provided there, it also obviates one of the other core handshake issues you see when somebody like an admin is doing an install and then handing things off to a developer or something along those lines. So in this case, all you need to do to use the install product is source the .env script that's within that product's install location, and then you're out to the races. No need to exchange information of, hey, where did you put it? And what do I need to set up and things of that nature? It's just all there. So you can kind of see the friction has been kind of greatly reduced from a development perspective, right? You've got this kind of click button interface for, put this over here kind of thing in my environment, and then a quick way to say, this is the one I want to use, and then you're off to the races. If you contrast that, and we'll go through that a little bit here in a couple of slides, you can see that there's a vast improvement over what typically happens today. So just to go, at a glance, because sometimes it's a bit difficult to understand or wrap your mind around sort of all of the different things that happen, or all of the different things we're talking about here. In this case, we've got the Red Hat OpenShift container platform. That's sort of the hosting environment on this. We had these certified or native operators. So in this case, we're talking about some of the other products in the stack. So you see Wazi Sandbox and zOS Connect and things of that nature. So these are the other products. In the bottom, you see the sub operators. So this is the part we're currently zoomed in on right now, right? And so zOS Package Manager is the tool which is responsible for doing the install of each of these other products into the zOS instance, right? So what it does is it says, okay, you say under the covers, the modernization stack will say, ZPM, I need you to install Python on this zOS host, and it will go off and do its work. The sub operators, you see we have one for C++, Python, Go, Node, Java, and ZOAU. So this gives you that very easy and slick install experience, right? And so on the bottom here, we have just to point out target environments. So these sub operators are targeted to zOS environments. So just to be clear, the idea here is these languages are going to be deployed into a zOS environment that you configure. You will provide a host name or an IP address, the credentials to said host name so that the install can be executed on your behalf. And then the automation drives that from there. In this other case, other platforms, you have access through IDs and stuff of that nature. So I just want to emphasize the point here that this is targeting zOS for install for these sub operators. So to touch a little bit on this .env script. So as I mentioned, this is one of the key things that comes here is the idea that you can just source this entity, and it's coded in such a way that when you source it from its install directory, it will set up your environment to successfully run that product. And then if you want to switch to another one, you just source that environment. In addition, if you want to do something along the lines of, I'm going to use Node and Go, right? You would source the Node version of this, and then you would source the Go version of this. And so it becomes very easy, again, to kind of set up environments in very programmatic and very streamlined ways. Okay. So let's kind of take a step back and think about, how does this help, right? We outlined some of the pain points or some of the important factors around modernization and momentum and things of that nature. So what is the improvement or what is the change we see here, right? So from a product acquisition perspective, we talked a bit about this, right? There's one place to get all of your packages, right? It avoids or eliminates this painfully seeking exercise, right? This painful seeking exercise for, what are the different versions? What's the right one? How do I make sure that this one's going to work with what I want to do with Python and things of that nature? You have less time wasted finding and getting products, more time developing. Okay, so there's less churn, less searching, less overhead for everybody in that sense. We have a simplified product version selection and configuration. So because you had this nice interface, right? You have this web-based UI to say, here's the different versions I have available to me. I'm going to click on that one. I'm going to click on that one. Click go. No more fumbling around to kind of find the right version. And if you've installed or tried to install some of the modern languages, you'll probably understand that there are different requirements and different processes to follow and things of that nature. So it's kind of a learning adventure on each path, right? And if enough time elapses between when you've done your first version of this and your second version of this, you've likely forgotten, or the details have faded, and you'll have to kind of rediscover those types of things. Not so when you use the modernization stack here. Easy deployment. So this is, I think, one of the key things. It's sort of a one-step thing. So in general, when you look at Python or something like that, we walk through sort of that process, right? Even though there's kind of 3 discrete phases to getting sort of a usable Python environment, you end up with 12 steps to kind of get that to happen, right? In this case, you're kind of there in Cloud Broker, and you say, I'm going to click deploy Python. I want the C compiler, and I want ZOE. So you can click all 3 of these at the same time, and then you're off to the races. And then repeatable. So this is, I think, the other key aspect. Very repeatable, because this is such a simple process. To do the same thing again is a matter of mouse clicks, as opposed to logging in, transferring files, things of that nature. So as it stands, this is quite an improvement on the various dimensions we talked about in terms of the important parts for modernization development. So how does this actually compare to today's approach? So let's kind of line them up side by side and kind of see. So you can already see, there's more steps and more gristle on the traditional approach, right? So we talked about finding the right version, even the product pages, and then what is actually available, right? Downloading them, uploading them to the host, so actually transferring the payload over to the host, understanding and reading the install docs. Okay, what do I need? Where do I need to put this? Things of that nature. And then repeating this on the desired machine. So you do this for one machine, and you have to do it potentially for other machines that you want to do this on as well. On top of that, you need to then relay install locations and configuration, right? So this is kind of a key thing, right? Where, where did you put that? And then, that kind of introduces a handshake over right there. Then of course comes the test and confirm, right? Oh, hey, it didn't install right, or things of that nature. So that's a tricky one. And then, of course, you need to document and retain how to create this environment, right? If you need to reproduce the environment, or let's say that this is going to go into production at some point, how do I actually make this environment real again, right, on a different machine? With the modernization stack, right, you load up your Cloud Broker instance, and you find the desired product solver creator. You pick the target host that you've configured within the tool to say, I wanted to install to these. You click install. And then you log in, you source the env script, and you're off to the races running, right? So it's a much simpler process here. I will point out that there's some upfront setup on the ZN Cloud modernization stack front, right? So there's definitely some configuration work and things along those lines. But what that one-time setup allows you to repeat this over and over, right? So it's one of those leveraged types of situations. Beyond that, what this does and what this enables is moving towards a more modern model, right? So I think this is a key thing, and one we're seeing more and more people have interest in, right? In the distributed in the container world, right? Application deployment is typically a case of, I have a base set of dependencies that I express in some form, whether it's a Docker file or something of that nature, right? And then these kind of get automatically installed for me when I instantiate an environment. So it's very easy for me to produce a standardized development environment or deployment environment, in fact of matter, for a given application. And developers are used to this technology, right? This way of doing this, and having the capability to be able to kind of move our environments around, right, and work in this kind of way. So beyond that, the ZN Cloud modernization stack moves us closer to this model. It's definitely not at the same model quite yet. But what it does let you do is some of these same things, right? Expressing dependencies in terms of a set of canned things that you've got in a container repository, as opposed to, references to things that live somewhere else. Deployments are automated and unattended and repeatable. So, that gets us closer to that, click the button and I have the environment type of thing that I have. And deployment is simple enough to equip developers to create their own sandboxes. And so I think this is the key one. While there's certainly the case that some developers may be able to conjure, a development environment with a Python install today, for example, right? Getting some more of the more complicated things like a C++ compiler or zOAU tends to pose more challenges. Yet in this case, what we have is click button accessibility, right? So it's now become possible to entertain the notion of, oh, maybe a developer can build their deployment environment on their sandbox machine, as an example. So that's key. So what does that translate into? What can you do, right? What is this enabling you to do, right? So from a system programmer and administrator perspective, this makes the journey a bit easier, right? Aside from having to kind of go read the docs, work through various things, understand, communicate, where things went, things of that nature, they have a much more standardized approach, right? The product discovery, the acquisition, the deployment are all streamlined. In my role as the lead architect for Python, I can tell you we get questions all the time around, oh, which version should I deploy and how do I deploy it and things of that nature. So this helps tremendously from that perspective. The deployments are easy enough to equip developers to do this on their own test machines or development environments. So this is what we were just touching on. The idea that, hey, maybe I can hand them the keys and they can kind of do that work in their transitory environments. Faster convergence, the ability to get to an actual working deployment is much quicker using this path, right? That's for a few reasons. One is the automation and everything that's driving it. Two is the versions and the things that are provided within the stack all work together. Okay, so you know that when I'm clicking the C++ compiler that's with the Python compiler or the Python interpreter, they're going to work together because they're there to work together. Beyond that, you have easy access to keep up to the latest and greatest versions. This is a very important thing in 2023 with the security concerns and things of that nature. Being able to kind of quickly get the latest version, try it out, run your tests, make sure that your applications, work and things of that nature. This gives you a very quick way to adapt and move through those types of things.
Yeah, quick question, if I may,
Sure.
and this one's from me. No one's posted in the chat. You mentioned being able to get your hands on the sub operators with ease from the cloud, the online cloud repo, the IBM. I forget the name you gave it. A lot of the clients that I work with in this space, their OpenShift environments on Z are disconnected. I'm assuming it's just as simple to bring those sub operators into a trusted repo within their four walls. So disconnected installs possible, yeah.
Yeah, that's right, Joe. So IBM Container Registry is where the de facto artifacts are installed, but there are indeed workflows that let you use tools like Scopio or things of that nature to pull down. So these are just OCI artifacts at the end of the day. So you can pull those down and rehost those in your internal repo as you see fit. Yeah.
Got it. Thanks.
Good question. Thank you. All right. So examples. Just to talk a little bit about modernization in general around languages to motivate the discussion around, well, where does this fit in the bigger context, right? So in this case, we tend to look at the traditional languages we have in the center, right? We have COBOL, PL1, Java, Kix, IMS, things of that nature. So these are sort of the things where you've got existing assets and existing applications, right? On the left, we've got new applications. So basically, these are new things you want to add in. And for those, we see people starting to reach for Python, Node, Go, and Java to write some of these, right? And then they use REST APIs here, as we see in the middle, the connecting bar here, to connect, right, these new applications to these old ones. So that's one common thing. On the right side, we have application extensions. And so, the same thing goes here, right? Let's say I want to call some kind of Python machine learning package to do some kind of analysis or some kind of inference on a piece of data, right? So I can connect that to a RESTful API, or I can use, in some cases, interlanguage communication between the applications as well. So these are kind of the primary ways we're seeing folks, do modernization in the context of their existing assets. So that's more to set the stage for what we're going to talk about next, which is, some specific examples around, well, okay, let's take things, right? So I touched a little bit on this one, right? Let's add some numerical analysis numerical analysis and visualization to an existing reconciliation program. So let's say that we've got some COBOL program that's doing some reconciliation of some ledger or something of that nature, right? So in this case, we want to prototype this. Let's see what I can do, right? Let's see what kind of picture I can come up with, right? And the team is like, maybe if I create a Python program that can use some of these standard product packages like NumPy and Matplotlib, I can deploy these kinds of things. I can do something quick and give us a new view of the data, right? So that means we need to deploy Python and zOAU, right? So Python for our actual programming development, and zOAU to consume some of the JSON reports that are stored in data sets. So let's assume that this reconciliation program's outputting data in that sort of form. So the integration plan here, right, is we have a scheduled invocation of this new Python application after a reconciliation run. So in this case, we're going to do something very disconnected, right? So rather than tie it strictly into the program, we're going to actually invoke it as a side task after the reconciliation job is run. And then we'll email the results, right? And then the outcome is, we've got a quick adoption here, right? We've got this numerical analysis and visualization that can be automatically generated after reconciliation runs using Python as the thing. So, today, the process we'd follow, right, is step one, you have this idea, the team gets together. Step two, you sort of got this prototype, right? So somebody can kind of take the data and say, okay, I'm gonna do this kind of sketch work in terms of, what is it going to look like for me to do this? Step 3 is build a development environment with these required languages. And this is where the tooling we're talking about comes in, right? And so this is where kind of the gristle hits the road. So if you've ever tried this in the past, right, you can quickly get to a prototype, and then the question is, well, okay, how do I get this deployed, kind of thing? And this is where kind of the sand gets poured into the wheels or the gears, right? And things kind of slow to a halt. And so you end up with requests and you're waiting, things of that nature. So, maybe it takes a week or 2 or 3 potentially to get something installed and have this actually running in place. So then you have to actually implement the actual prototype in terms of getting it looped into the actual system using these modern languages. And then, of course, you have your integration, and then you end up with new functionality. So in terms of context, I think the idea here is this is where that stuff we've talked about in terms of a better way to deploy tools comes in, right? The step 3 is the place where you see this application, right, and you see the impact from what you've got there. So to take a slightly different twist, a quicker example here, right? Adding anomaly detection to reconciliation processing. So in this case, we're going to do the same type of process, right? We have a prototype we want to do, but instead of some kind of scheduled job, we're going to actually wire up a RESTful API. Same things roughly apply here, right? And again, the same issue is, if we don't have an existing Python environment, or let's say we'll use Node for this example, right? Or you could use Node for this example. Being able to conjure that environment and actually get to a place where, okay, I'm on zOS and I can actually invoke this thing is where you're going to see these steps really kind of show. Okay. So just to really drill into the specific things, right? Building a Python environment the old way. I want to recap and sort of take you to what specifically this looks like, right? In today's parlance, you need sort of a Python interpreter, a C compiler, and zOAU. So we've talked a little bit about this, right? You have to visit the Python product page, find out what version you need, download it, transfer it, install, right? Okay, you've got Python. So now you need the zOAU, same thing. You got to make sure you get the right version of zOAU and take it from there. So now you've got the Python and zOAU, and then you realize that when you try to install zOAU using pip, you need to C compile it. So now you need to figure out how to get C compiler installed. That typically requires system programmers and things of that nature. And then finally, you get down to a point where you've got a working Python and zOAU, which is great. And then if you need to do that again, you have to go through all of those steps potentially again on another machine. That's really, really painful. Contrasting with the new way, right? We've got this discovery, this deployment and configuration. That's a much simpler entity, right? So again, you go through the Cloud Broker UI, you have these 3 sub operators. You say, I want to instantiate the Python one, I want to instantiate the zOAU one, and I want to instantiate the C one. Each sub operator gets invoked. The automation installs the product. It's done. This takes a few minutes. And then you go and you source the .env files for each of those 3 products, and then you're done. So you can see that's a much easier thing for us to repeat and actually go through. Building on that, so let's say we want to make things a little bit more complex, right? We're going to weave a multi-language application together, right? So what if we want to add Node, Go, and Java components to the same environment, right? So as we talked about, that's going to require you to repeat all of those steps again, right? You're going to have to go through all of those different discovery processes and installation handshakes for each of those products in turn, right? So that means you could be doing this for up to 6 different installation processes, right? So that's really painful to kind of build that, right? If you contrast that with building the same thing out using the cloud and modernization stack, it's literally 6 click button installs and then sourcing the various .env scripts, right? And so you've added a lot of capability to your development environment with much less effort in this case. So this is where it really starts to shine, and the fact that you can repeat this again really shines here. So just to summarize, I want to bring it around to kind of the end here, right? Modernization products are delayed by logistics of environment building and deployment. We see this all the time, right? Folks are struggling with, how do I get the right version deployed? How do I manage them? Things of that nature. Getting the right tools and the right versions and the right developer configuration is also something that's not straightforward or not trivial today. So there's a lot of handshake and a lot of discussion and things of that nature. involved. And then traditional methods face many challenges in providing these capabilities, right? Because of the nature of the handoff and the domain knowledge, there's a lot of struggle between the two. With IBM Z and Cloud Modernization Stack, we offer a new experience, right? It's designed to support these capabilities, right? And it really starts to shine through in these modernization examples specifically. Environment composition is modeled after modern container-based approaches. So this is key, right? This is moving everybody towards more of this standardized and more broadly understood method for composing deployment environments. Simple and streamlined access to versions right out of the box. This is key. This is something that's been a major pain point for folks. And so, having this one place to get everything. And as Joe referenced, you can even mirror this to internal repositories to match current isolation requirements and things of that nature. And then the fact that this is easily repeatable, I think is really going to facilitate this rapid environment deployment in terms of getting people the ability to rapidly conjure or get to things that are useful for them quickly. Okay. So I've left a few references here in the links here, just in case you're interested in checking out some of these things. There's some documents around how it works and also the workflows that are enabled there as well. So those are there for your reference. And with that, I think that brings me to the end. So if there are any questions, I'm happy to take them now.
Thank you, Chad. The chat is clear at the minute. We've got a bit of time. So yeah, if anyone has a question, please feel free to post it now. Thanks for that, Chad. Really interesting session.
Cool.
Just give it a couple of minutes, see if we have any questions. You got a thank you, but not a question.
Not a question, but thank you for the thank you.
Rune Christensen asking if you've got time to demo this. 23 minutes, no pressure, Chad.
Unfortunately, I don't have time to demo live. That requires me to have OpenShift environments and stuff like that nature handy. What I can do, if you'd like, you can reach out and I can get you some demo materials offline to go through that.
Perfect. That answer your question, Rune? Happy with that? Yep, happy with that. Any more for any more? Final call? I think that's it, Chad. Okay,
all right.
Thank you, guys. This was session 9D. Like I said, don't forget to submit your feedback, and thanks for joining. Looking forward to seeing you at the next session, which is at 3:30 UK time. Thanks, everyone. Cheers, Chad.
Thank you. Cheers, guys.